Let us illustrate how to evaluate the determinant by first bringing the matrix to the upper triangular form. So consider the determinant of this 3 by 3 matrix. Here we have a non-zero number, so we can write 2, 1, 0. Now, to get 0 instead of 3, we take 2 times the second row and we subtract 3 times the first one. This is an equivalent operation in the sense that it does not change the rank of the matrix, but it is not equivalent when computing determinant. We can add a multiple of another row or a linear combination of another rows to a given row, and that does not change the determinant. Once again, if we add a linear combination of the remaining rows to a given row, this does not change the value of the determinant. And similarly for columns. If you take a column and you add to this column a linear combination of the remaining columns, this does not change the value of the determinant. But multiplying one column changes the determinant by this factor. So if you take the second row and you multiply by 2, this will be 2 times higher. So we must divide by 2. And then we can perform this operation. 6 minus 6 is 0. And then 2 minus 3 is minus 1. And then 4 minus 0 is 4. And similarly, to get 0 instead of 5, we take 2 times the third row and we subtract 5 times the second. And that will be the new second row. But when we multiply the third row by 2, we increase the determinant in this factor 2. So we must divide by 2 once again. And then we have 10 minus 10, which is 0. 3 minus 5, which is minus 2. And finally, 2 minus 0 is 2. Well, and now we can reduce this number to 0 by taking the third row and subtracting 2 times the second. And the third minus 2 times the second will be the new third row. So we copy this factor 1 over 4, and we have the determinant of the matrix 2, 1, 0, 0 minus 1, 4, and here we have 0, minus 2, plus 2 is 0, and finally 2, minus 8 is minus 6. And if we multiply 2 minus 1 minus 6, we get 12 divided by 4 is 3. We can check this by evaluating the determinant in another way. We can use the Sarus rule, namely to compute this product. 2 times 1 is 2, plus 10, plus 0, minus 0, 3, and finally 4. So we have 12 minus 7, which is 5, Something is wrong. Okay, let me check this.